In section 2.2, we're going to discuss what a biconditional is. We're going to talk about the relationships between conditionals and biconditionals, and then we're going to use biconditionals to determine if a statement is a good definition. Okay, so what is a biconditional? A biconditional is a statement that you get by combining the conditional and its converse into one statement. So instead of saying if, then, and then saying if, then the other way, you make one statement and you put the phrase if and only if, usually in the middle, but it can be on either end if you want. The shorthand version of if and only if is IFF, so if your hand gets tired and you don't want to write if and only if, you can just write IFF. So first example, what two conditionals make up the following biconditional? So this is a biconditional. We know that because it's got the phrase if and only if in it. An angle is a right angle if and only if it measures 90 degrees. This is what we would consider a good definition. If you look at what two conditionals make up that biconditional, we would write that let's see if I can find where I'm going here. If an angle, remember that's our subject, if an angle is, and you can say is a right angle or is right, depending, I'm going to just say that because it's shorter, then it measures 90 degrees. Okay, so we know that this is a conditional because it would say if and then, if an angle is right, then it measures 90 degrees. Its converse, remember we leave the if and then there, and we leave the subject, if an angle. But then for the converse, we switch the hypothesis with the conclusion. So we would say if an angle measures 90 degrees, then it's a right angle. Okay. So those would be the two conditionals that go together to make the biconditional. For a biconditional, you can put the hypothesis and the conclusion in either order. So you could say an angle is a right angle if and only if it measures 90 degrees. You could also say an angle measures 90 degrees if and only if it's a right angle. So you can make a biconditional, you can put the hypothesis and conclusion on either end as long as you put the if and only if in there. And sometimes they put the if and only if at the beginning. So it'll say if and only if an angle is right, it measures 90 degrees. So most of the time it's in the middle, but once in a while they do put it at the beginning. How do we use these? We use biconditionals and conditionals to look at whether or not a definition is a correct definition. We do that by we take the statement and we put it in conditional form. So whatever the statement is, in this case we did, we said if an angle is right, then it measures 90 degrees. Then we write the converse. So we wrote the converse. In this case, we knew it was true, but you would check to see if both are true. So if an angle is right, then it measures 90 degrees. That's true. If an angle measures 90 degrees, then it's right. Both of those are true. So then we would say that the biconditional makes a good definition. If it wasn't already written as a biconditional, then we would write it as a biconditional. In this case, it already was. So to write a statement as two conditionals and decide if it's a good definition, to follow these checks and balances, so to speak. Here's our statement. A triangle is a polygon with only 3 sides. So we start by changing it into a conditional. So if, and what's our subject? Polygon. Okay, so if a polygon is and I'm just going to abbreviate, triangle, then it only has 3 sides. Okay. Converse, so we start with if a polygon And then we we switch the hypothesis and conclusion. If a polygon only has 3 sides, then it is a triangle. You check to see if both are true. If a polygon is a triangle, then it only has 3 sides. That would be true. If a polygon only has 3 sides, then it's a triangle. That would be true too, because by definition a polygon is a closed figure with segments for sides. And so if it only has 3, so we would say check. And that is true. Since both are true, it makes a good definition. So our conclusion would be to write this as a biconditional. So we would say a triangle is a polygon, and we would write if and only if it has only 3 sides. Okay. The symbol, remember that the symbol for conditionals is the single arrows, the hypothesis, then the conclusion, then the hypothesis. This would represent the original conditional. This would represent the converse. If you put them together to make a biconditional, we change the arrow to a double arrow, and you can put either P or Q on either side. So the symbols would look like this. P, if and only if, Q is how we would say it. That's the end of this lesson. Please check your pacing guide for your suggested problems.